Nylon is a polymer, a plastic with super long, dense molecules built up of short, endlessly repeating sections of atoms. Nylon is actually the name for a whole family of polyamides, rather than one substance. Developed in the 1930s by American chemist Wallace Carothers, it took him 7 years to perfect the process, with the DuPont chemistry conglomerate presenting the new miracle substance at the New York World Fair in 1939. Advertised as the first man-made organic textile fiber, its versatile properties made it a strong replacement for natural resources such as silk and cotton, being cheaper and easier to manufacture in America instead of purchasing from Japan. Initial uses for nylon included replacing silk in stockings and clothing. However, when the Second World War hit, manufacturing priorities shifted to the war. As a result, nylon was used in parachutes, ropes, and water-repellent uniform and tents. Nowadays, pure nylon is less common. Instead, it is often blended with other substances to produce various materials that still retain the strength and versatility of nylon. Many of today's products utilize nylon due to its abundance of useful qualities. Toothbrushes, fishing nets, umbrellas, food packaging, carpet, alarm clocks, even the first flag planted on the moon are all made of nylon. However, the commercial nylon creation process also sprouts multiple environmental concerns. Many manufacturers use crude oil to isolate polymers, resulting in a depletion of natural fossil fuels and an increase of environmental pollution from waste products. In addition to this, a chemical production of adipic acid frequently creates nitrous oxide, a potentially ozone layer eroding greenhouse gas, which worsens nylon's impact on the environment despite its ability to be recycled. Nylon is no doubt one of the great symbols of the technologically revolutionary century, and has and will continue to benefit the consumerism of humanity well into the future as the world's most useful synthetic material. A strong synthetic fiber, nylon is hydrophilic, resists abrasion, and is a flame-resistant and retardant material. Though it does not shrink or stretch through washing, it is capable of being degraded by ultraviolet light. While I use silvicoyl chloride and hexane to form 6,10 nylon, the more commercially produced substance is 6,6 nylon. Nylon 6,6 can be made from two monomers: hexandioic acid, more commonly known as adipic acid, which has acid groups on each end of its chains, and 1,6-diaminohexane, more commonly known as hexamethylene diamine, which has amine groups on the end of its chains, both molecules having chains of 6 carbon atoms. When the two monomers react together, a molecule of water is produced as each link is formed. The monomers continue to link together, forming long-chained nylon salts as the product. The nylon crystals are then soaked in water to dissolve them, then acidified and heated to create a chain that is nearly unbreakable on a chemical level. Manufacturers typically use a specifically designed machine, such as the Jordan machine, to heat the polymers to the right temperature, which then makes the molecules combine to form a molten substance. In a spinneret, the substance is separated into thin strands and exposed to air to harden instantaneously. Once hard, they are wound onto reels. The fibers are stretched to create strength and elasticity to the desired attribute, resulting in the finished product that is nylon. This is the process of making nylon 610 through polycondensation. Here I have two solutions. Solution A, the colourless solution, is 2 ml of silvicoyl chloride, which has been dissolved in 50 ml of hexane. Solution B, the pink solution, is 2 grams of 1,6-diaminohexane in 50 ml of distilled water, with a few drops of alcohol dissolved phenolphthalein. Using the funnel, I pour solution A onto solution B, forming a skin boundary between the two solutions. Then I lift the skin carefully using the tweezers, and I wind the string of nylon skin onto a rod. Currently, the long chain of polymers are jelly-like and pretty much useless. Further treatment would be needed to create the infamously versatile, hardened nylon strings.
Kelly, can you handle this? Michelle, can you handle this? Beyonce, can you handle this? I don't think you can handle this.
Using water, we rinse away the acid and primitive nylon is made. This is incomparable to the manufactured nylon that is made in factories. However, this is the limit of our school budget, so...
Yeah, good. It's not like it's good. That hasn't been...